Hello everyone, welcome back to our channel. So today we are going to see the remaining modes of convergence. First we will see about the quadratic mean, then we will go to the distribution. Rth mean we can also call it as quadratic mean. Now the definition is, for all the definitions of modes of convergence, the first line is same. Let xn is nothing but the sequence of random variables where n is greater than or equals to 1. The sequence of random variables convergent to random variable x in quadratic mean for some r greater than or equals to 1 and expectation of mod x to the power of r and expectation of mod xn to the power of r is finite. That is, limit n tends to infinity, expectation of mod xn minus x to the power of r should tends to 0, which is nothing but limit n tends to infinity, expectation of mod xn minus x to the power of r which is equals to 0. ఇక్కడ ఏంటంటే ఒక సీక్వెన్స్ తీసుకున్నట్టయితే ఆ సీక్వెన్స్ ఆఫ్ ర్యాండమ్ వేరియబుల్స్ అనేటివి కన్వర్జెస్ టు ఎక్స్ అవుతాయి అన్నమాట ఇన్ క్వాడ్రాటిక్ మీన్. వెన్ ఇట్ విల్ కన్వర్జ్ to the random variable x in quadratic mean if for some r should be greater than or equals to 1. Here r should be greater than or equals to 1. If r is not greater than or if it is less than or equals to 1, which is nothing but r can be 0. If it is 0, anything to the power of 0 is 1 and anything to the power of 0 is 1, right? And we have condition this should be equals to 0. So it is mandatory that r should be greater than or equals to 1. And here expectation of mod x to the power of r and expectation of mod xn to the power of r is finite, which is nothing but expectation of x to the power of r and expectation of mod xn to the power of r is less than infinity. This 2 should be less than infinity and r should be greater than or equals to 1 and it should satisfy this condition. Then only we can say that the sequence of random variables is convergent to the random variable x in quadratic mean. And if this r is equals to 1, if this r is equals to 1, we will say that the sequence of random variables is convergent to x or a random variable x in mean. If r is equals to 1, then the sequence of random variable is convergent to x in mean. If r is equals to 2, then we will say that xn is convergent to x in quadratic mean or rth mean. And we also have the implication, that is, if sequence of random variables is convergent to x in quadratic mean, it implies that the sequence of random variables is convergent to x in probability also. This is the implication. And counter implication is, if the converse is not true. Here if it is convergent in quadratic mean, then it implies it convergent in probability. But the converse is not true, which is nothing but xn convergent to x in probability does not implies the sequence is convergent to x in quadratic mean. This you need to remember. This is nothing but the implication and these are the counter implications. And when we can see that the sequence of random variables x is convergent to in probability, that it also convergent in quadratic mean in a case where these all sequence xn's are almost surely bounded almost surely bounded, which is nothing but mod xn, which is equals to mod xn of omega is less than some constant, let us say m. And we know that what is a bounded condition? Bounded is nothing but mod a is less than some constant value m. This is the condition for the bounded. So please do remember, whenever the sequence is convergent in probability, it is also convergent in quadratic mean if and only if these sequences are almost surely bounded such that mod xn of omega is less than some constant m, where omega belongs to omega. Omega belongs to omega. This omega represents the possible outcomes, which is nothing but the favorable outcomes. This omega represents the sample space. The both terminology is same, but the characteristics is different. Okay. And now we will see about the distribution, the last one. Distribution or law. Let us consider for xn, as we are talking about the convergent in distribution or convergent in law, we are talking about distribution, right? So for the sequence of random variables xn, let fn of x be the distribution function. Okay? And for a random variable x, let the distribution function be f of x. And we can say the xn is convergent to x in distribution if fn of x tends to f of x, which is nothing but if for every point of x, if f is continuous at every point of x, this f, which is, if this f is continuous at every point of x in a sequence, then we can say that the sequence xn is convergent to x in distribution or law. This is nothing but the distribution. Convergent in distribution. And this can also be called as convergent in law. And this is the weakest form of convergence. Weakest form of convergence. The distribution is weakest form of convergence, and in modes of convergence, the most powerful is quadratic mean. Quadratic mean. And this convergent in distribution or law is used in weak law of large numbers, central limit theorems, etc. These are the applications that we can say for the distribution. And this is about the remaining modes of convergence, that is quadratic mean and distribution or law. And in the next video, we are going to see about the relationships between the four modes of convergence. What is the relationship between convergent in probability, almost sure, quadratic mean, and law? This we are going to see what is the relationship between probability and almost sure, probability and quadratic mean, probability and law, almost sure and quadratic mean, almost sure and law, quadratic mean and law. Okay? And till now, stay tuned to our channel, Sunaina_MSc. Thank you all for watching my videos.